My name is Ana Perez. I am the Associate Director for Water Quality for the Great Barrier Reef Foundation. So thanks a lot for joining us today. I'd like to start the webinar by acknowledging the traditional owners of the land in which we meet today in Brisbane, that is the Jagera and Turrbal people. And I would like to pay my deepest respects to the elders past, present, and emerging. So this is the first of our water quality webinar series. So we are very excited about that. And we have a good audience today, which is really great. The webinar is being recorded, as you know, so we will be able to post it in our website later on so that anyone who couldn't join can watch the webinar. The topic that we are covering today is innovations in reducing erosion and fine sediment loss. And we have 4 projects that we'll be presenting today in their innovation projects. Thanks to the presenters that they are all in the screen. So in terms of the agenda, what we're going to do is that I'm going to do a very brief introduction of the RTP and the work at the water quality component. And that will be followed by the 4 presentations from our project. So each project has something around 10, 12 minutes to present. And after that, we will have some time to allow for questions. So yeah, I think that's all for now. Colby, could you please pull out my presentation to kick off? Excellent, thanks. Okay, so before we jump into the presentations, very quickly, I'll give you an overview of the water quality program and the efforts that we're doing to reduce the amount of sediment that flows to the catchments from the reef. Next one, Colby, please. So the one before, most of you are familiar with the RTP, I guess. So the Reef Trust Partnership, it is a partnership between the Australian government and GBRF. The total amount of funding is $443 million, and those are to be spent in 6 years. That ends in June 2024. The aim of the RTP is to achieve a significant and measurable improvement in the health of the Great Barrier Reef. So that's our aim. Next one, please. So from the $443 million, $200 million have been allocated to the water quality component. And this graph shows how this money is going to be spent through the different work streams that we are funding. So although our emphasis today is on the innovation and system change program, in the next slides, I'm very quickly going to show you some of the work that we are doing to reduce sediment through the other work streams of our work. Next one, Colby. So I'm going to start with the early investments. So these were 11 projects that we funded. They were contracted in between 2018-19. They all have been completed now. And the intention of these projects was to maintain the delivery capacity in the regions while we were going through our planning phase. 5 of these projects were focused on reducing sediment, and they have been able to deliver very important outcomes in terms of erosion control. So you can see in the screen, they have been able to save 14 kilotons per year of sediment flowing to the reef. A number of gullies have been remediated. Most of them were type 1 gullies, but there was one type 3 gully as well. Almost 10 kilometers of stream bank restored, between other very important outcomes. Next one, Colby. And now this work stream, it's the regional programs, which is the one that has the bulk of the funding. We're talking about $138 million. This is also where most of the erosion control on-ground activities are happening. So just to provide some context about the regional programs, at the very beginning of the RTP, we did some modeling work. The idea was to identify how and where our interventions could be more impactful. We wanted to address the highest priority pollutants and to work in the highest priority catchments. So that modeling work led to the map that I'm showing here, which essentially tells us how much money we should be investing in each region in order to deliver the highest reductions in priority pollutants. So we identified 10 programs, 5 focus in cane to reduce DIN and pesticides, and 5 focus in addressing sediment, which are the ones that are with the circles. The total investment of in these 5 regions to address sediment is of $62 million. And as part of these programs, we also develop specific targets for the programs and the projects on itself to reduce pollutant reductions. For sediment projects, in total, we have a target to reduce 463 kilotons of fine sediment. Next one, Colby. So the next work stream is the conservation and protection work stream, which is focused on less disturbed catchments. So 9 of the $11 million that have been allocated to the Eastern Cape York program. This program has 7 projects underway. All of them are focused on sediment. And these projects are a bit different from those under the regional programs because they have a focus on conservation, land management, and they do not have targets in terms of sediment savings. The main 2 organizations that are leading the work on under this work stream are the South Cape York Catchments and the Cape York Water Partnership. These 2 organizations are working with traditional owner groups in most of their projects. And these projects are addressing a variety of issues, as you can see, from gully remediation, practices to reduce road erosion, wildfires, etc. The focus today is in our innovation program, which is it's designed to trial innovative technologies that so that we can get better at implementing water quality improvement activities. So we want newer, better practices, tools to be available for farmers, graziers, new systems to support decision-making, more funding resources to support water quality improvement. So thinking of that, we identified 4 areas of investment that you can see in the slide. So technology transformation, working with data, working on planning for future interventions, and also innovative ways of funding and financing different initiatives. We identified 22 projects under a procurement process. Some of them are finalized, although most of them are still being implemented, and actually 6 of them have recently been extended, given the potential that they have to lead to a step change into the way we do things. Next one. So these are the 4 awesome innovation projects that we are going to be present today. I won't get into any detail because we'll have plenty of time to talk about them. Thanks again to all our presenters in advance for sharing with us the great job that you are doing. All these projects are obviously focused on applying innovative approaches to reduce erosion and sediment loss. But we do have a few more projects which has the same objective that they may be, well, we may showcase them in the next webinar. But just as a very quick overview of the other type of projects that are in the mix, we have, for example, next slide, a project undertaken by Alluvium that is focused on improving the design of pile field structures. Another one exploring the additional benefits from gully remediation activities to reduce bioavailable particulate nutrients that is being implemented by Greening Australia. Griffith University is also implementing a very cool project to develop like some kind of weird algorithms to reprocess extremely large data sets of LiDAR data. We have CSIRO also undertaking a project to make available products to identify the gullies and the stream banks with the greatest potential risk for erosion. So these will assist in setting the priorities for erosion control in the future. And last in the slide are two different projects that are part of the innovative funding thematic area. One of them is aimed to create a globally significant impact investment fund with the idea to, well, it is for large scale landscape interventions. The second project is to transition the Reef Credit Scheme from the very start up to a fully operational environmental market. Next. Okay, so that's all I have to say before we jump into our very first project. So thanks very much, Beck. Rebecca Bartley from CSIRO is presenting on a project. And if you could pull that up, Colby, the name of the project is Understanding the Role of Regenerative Grazing Management Practice in Improving Land Condition and Water Quality. So take it away, Beck.
Lovely. Thanks, Anna. And hi, everyone. I'm going to jump straight into it because we don't have a lot of time and I've got quite a lot of data to share with you, but just a few acknowledgements to start with. The team, it's CSIRO partnered with University of Southern Queensland, NQ Dry Tropics, and an acknowledgement to Christian Roth, who's also been involved in this work from GBRF. Acknowledging the funders also and the traditional owners on the lands that this work was undertaken, which is largely the Burdekin region. So next slide, Colby. So I'm guessing most of you have heard about the term regenerative agriculture, and today I'll switch that to regen grazing. It's making some pretty big claims all around the world. It's out there suggesting it can solve everything from climate change to fast fashion, and it's also been suggested it can do a lot for improving water quality to the reef. That hadn't been tested until now, and so we set up this project to actually see whether, if we could demonstrate that there are benefits from regen grazing principles, it could actually be a really big game changer for the reef, given 75% of the area draining to the reef is under grazing systems, usually rangelands. On the other side is if we could demonstrate that it actually didn't have much of an effect at all, it could save a lot of money that would have been sent out to pretend that you were actually improving water quality when you may not have. So it was quite an interesting project to get involved in. Next slide. What I'm going to just cover off on today is the key focus of the project is on the biophysical outcomes of regen grazing. If anyone who has danced around this issue, you'll know it's a bit of a religion. It's quite contentious and there's a lot of opinion. I'm not going to get into the discussions of how people get to the type of regen grazing, but what we're interested in is the outcomes after people have done it in terms of the biophysical form. The key thing to probably mention, though, is the difference between regen grazing and other forms of, normal grazing land management. There's probably two differentiators. There's one is that often has high rotation. So a lot of properties may go from 5 paddocks to 50 paddocks. And then they will often rotate their cattle around in high density mobs, leaving the other areas under large temporal periods of rest. So it's high density and rest. So we've got two components of this project. The first bit was largely a space for time approach where we measured vegetation and soil attributes of about 6 properties in the Burdekin. We did this over a 2-year period, but one wet season, a before and after, using fairly tried and tested techniques around bottonelle and patch key, as well as some remote sensing data collected on each property. And then the soil condition analysis was largely around carbon, nitrogen, and soil moisture. We can't in 1 year get the outcomes of any water quality measurements from that. So what we then tried to do was the second part of the project was at one of our long-term monitoring sites in the Upper Burdekin, Virginia Park. We have 18-year record of vegetation, soil condition, as well as runoff water quality, and it will give us loads. So we thought that if we could calibrate the current paddock to reef models, which is largely how leaky and grass to that site, using that long-term record, we would then be able to use that modelling component to test whether regen grazing would have that flow-on effect through to water quality. Unfortunately, that last bit of the work, bringing it together, isn't quite funded here, but I think we're not too far off being able to do that. Next slide. So what I'm going to do now, we've collected a lot of data actually in just the 18 months this project's been going, and I can't show it all to you in 10 minutes. I'm going to give you a bit of a snapshot of some of the findings so far. Just the actual design first up is we had the 6 properties, and I've de-identified them here because most of the landholders have been asked to be de-identified. So we have properties regen site 1 to 6. Site 1 is what we called, it was just a mixed management site that's had a combination of wet season spelling and sort of what you'd call regional average stocking conditions. R2 to R4 are our regenerative grazing sites, and they've all undertaken, they've split up a lot more paddocks, a lot more watering points, and the key difference here is they all rotate their cattle in high density. The difference being R2's only been going for about 5 years, R3, depending on which paddock, around roughly 10 years, and R4 hitting just about 20 years now. Our R5 site is one of the actual long-term, very old DPI exclosure plots where there has been no grazing for 30 years. And R6, I can probably tell you that's our Department of Defence lands in the Upper Burdekin, where again, they've had very minimal to no grazing for 40 years. However, they have a much more frequent fire through the system, and they do bomb stuff and run tanks up there, but no cattle. So just next click. So for each of these sites where we had 1 hectare plot set up, we also set up a coincident control site. So wherever we could, the control was on the same property or on the neighbouring fence line if they had friendly neighbours who had different grazing conditions to them and were happy for us to enter the properties. The control sites are a bit, the main thing to know is they actually had no specific grazing management. Often they could be set stocked, they could have been a sacrificial paddock, it could have been a holding paddock, it could have been let go for a while, but there was no specific management. But same soil, runoff aspect and slope as close as we could get to the treatment sites. So into some of the results, next slide. So lots of data here. These are box plots by pre and post wet season and control and treatment, but just to get your eye in, I think the key thing is to look at your green ticks here. This is total percent cover, comparing the difference between the treatment and control for each of these properties. And you'll see in dark green, we actually did get a statistically significant difference at R3, R4 and R5, which is great for both pre and post wet season. Interestingly, R2 also got a significant result, but only for post wet season. So that's an early good news indicator. And noting that R6, there is no actual control. It's more as a benchmark for us to compare what's going on in terms of systems. So next slide. The next attribute is biomass that I'm just presenting, which is to me a much better surrogate for likely hydrological, eco-hydrological condition. So it tells you the volume or the biomass of the pasture that's out there. And we've got very similar results again, R3, R4, R5, giving us statistically significant findings. And this time R2, partial significant results and nothing different at R1, which was interesting in its own right. And next slide. And just one of the other vegetation attributes I wanted to present was grass basal area. And this is basically a good indicator, again, of hydrological condition. It often tells you how many tussock grasses you've got in your system, which are really like good windows for getting water into the soil. And the more you can hold the water in the soil, the less it's likely to run off. Interestingly here, we only got significant differences for the longer term sites that have had cattle, either different management or cattle exclusion, and they were at R4 and R5. So, and basal area often in terms of recovery will take a lot longer to recover than things like cover and biomass. Next slide. So this is the only other bit of data I'll show you for this, and this is total organic carbon in the soil. And so this one's obviously carbon's a very topical issue at the moment with the Emissions Reduction Fund having its carbon method. But just a note that carbon can be a bit tricky to interpret. Good news is we did get, again, a significant difference at R4 and R5, but we also got a significant difference back at R1, which didn't actually have any differences in their vegetation attributes. So we're actually not quite sure what is going on there. But I think it just highlights that carbon, as much as everyone's slightly obsessed by it at the moment, it's quite difficult to measure. It's highly variable. It will change with rainfall and soil type. And even things like, if you look at site R3 here, actually has high natural carbon, but it has high carbon in the control site, which we actually know was quite flogged. It was in pretty bad condition. So whatever's caused it to have high carbon there, it's probably not the management. So next slide. So because we only had a snapshot in time, we also tried to get the remote sensing data, which takes us back to a 30-year period to 1990. And there's a lot of data on the screen here, but this is actually the detrended, or what we call delta cover, which is our cover back in time, largely detrended for climate, because we know grass basically corresponds to rainfall a lot. So next slide. And just honing in on that red box, this is the one site where at R5, where we actually did have statistically significant improvements or differences between control and treatment, between cover, biomass, carbon, species composition, basal area, and litter. So they got the gold prize out of these sites, which is pretty good news. And you can see through the remote sensing record roughly when they change relative to their neighbour, and you can see that departure and improvement in their landscape. Next slide. So just on component 2 of the project, just really briefly, many of you have probably seen these videos from many years ago at Virginia Park Station, where we've been monitoring the actual real runoff and water quality over time at different sites. Next slide. The benefit here is we've been able to capture some of the actual dynamics in vegetation response from 2003 through to 2020, as well as the coincident water quality responses at this site, which has been really helpful to then constrain the models and actually calibrate. And just to show you, next slide, a little snapshot into what this means in terms of real water quality and cover. So back in 2003, you can see on a hill slope, all those red patches are actually bare ground. So that's where you're getting quite high sediment concentrations through time. This site has actually did have managed livestock control through the first 10 years, where we destocked. And you can see by 2010, unfortunately, cloud cover obscured the remote sensing here, but you can see it's a much bluer pixel cover here, which actually is your ground cover. And that increase in ground cover decreased your sediment concentrations, which was great. However, by 2015, it starts getting patchy again, just showing here that how fragile these landscapes can be. And as a result, water quality concentrations started to go back up, and they've dropped off again by 2020. So look, behind this, I've got a lot more data in terms of the hydrology and what this means for the models, but I think it's a fairly unique data set in that I think it's the only one in the GBR where we actually have measured data on recovery over such a long period of time in terms of grazing systems. So this will be, 20 years this year. Next slide. So just wrapping up, I think the good news is, and the 2 bits of work at the moment are in prep to go into review. So I don't want to say too much before these things get peer reviewed. But essentially, I think it's a good, an interesting insight and early signs that the regen grazing, if done well, can offer some really big benefits in terms of land condition, vegetation attributes, and soil carbon. What we've found, again, that percent cover is the key metric that's used in a lot of the paddock to reef models, informing the Reef 2050 plan. But it's not the best metric, and things like biomass, basal area, species diversity, litter, and other things are probably much better at actually representing the hydrological function and land condition. But they're really annoying to be able, and we can't currently predict them, although biomass, we're getting close from remote sensing. There's also other quirks when you're doing data analysis like this between variable climates, fire frequency and tree density can obscure some of the results in terms of recovery. And generally, I think we've highlighted here that it'd be great to have more sites like this, more data to look at this recovery pathway. But the feedback from landholders during this project has been that they'd really like some numbers now on the economics for this work, which we didn't get to. And it has provided some really useful insights between the the data, how it works on the ground in terms of data collection through to the remote sensing products and then the models. But I'll have to give another seminar when we finish that work about the modelling outcomes. Thank you, Anna.
Excellent, Beck. Thank you so much for that great presentation. Oop, I lost you. So let's give it a look. We don't have any questions at this stage. Just a reminder, please, that you can use the Q&A function at the bottom of the page to send your questions. And if you're having any issues, please just use the chat.
Most people should know where to find me. I'm happy to take questions via email if they come up later as well.
Okay, excellent. Thanks, Beck. And we will also be sharing with everyone the presentations and the contact details of everyone. So yeah, so you can get in contact in case you have any questions directly. Okay, we'll get ready for nice work, Beck and team. That's on the chat. Okay, so we will allow some more time at the end in case anyone has more questions for Beck. Colby, can you bring please the next presentation? Our presenting is Megan Forrest from the Local Government Association of Queensland. Take it away, Megan.
Thank you, Anna. Hi, everyone. So as Anna mentioned, my name is Megan Forrest and I am the project manager of the Cleaner Road Runoff project here at LGAQ. Just to quickly let you know, Local Government Association Queensland, we are the peak body that represents all local councils here in Queensland. They are our members and our role is to really advocate for them on key issues. The Cleaner Road Runoff project is an initiative that came out of our Reef Council's rescue plan. That's something that we've worked on for quite a long time with our Reef Councils that we engage with. And the project has a fantastic team behind it. I just want to note our incredible project advisory group, where we have representatives from Griffith University, the Institute of Public Works, Engineering Queensland, as well as key councils and our consultant team who are working with us as well. Next slide, please. So why unsealed road runoff, or why cleaner road runoff? So with this project, we're really hoping to deliver innovative road design and management practices for unsealed roads across Queensland to help improve water quality targets for the reef. Now, as I mentioned, we work with 32 reef councils or reef catchment councils, 19 of which are part of the Reef Guardian Council program. Across that network of our local councils that are within reef catchments, a conservative estimate for this project at the moment is that there is at least 45,000 kilometres of unsealed road that our local councils manage. Now, those councils are responsible for that and have seen over the past few years, or forever, I guess, big rainfall events will occur, and there is mass material loss, a lot of erosion from these unsealed roads. Again, a conservative estimate at the moment is about 25 millimetres of pavement material is lost per year when we enter those wet seasons. So at the LGAQ, we identified that this could be a very large scale potential impact on finer sediment making its way into Great Barrier Reef catchments, and is a key issue that our councils are very passionate about and want to get on board in solving. So that's a bit about the why. Next slide, please. So what is the project? As I mentioned, the key aim is to, it's kind of twofold. So the first one is to actually establish a baseline. What is the actual impact of unsealed roads in sediment runoff? Because we don't really have that baseline yet. And second is to identify what are some innovative design and maintenance practices that we could implement to help reduce that sediment runoff from unsealed roads. just to let you know where we're at with the project, we got funding in May 2021. Where in the initial stage, we did some project scoping. What was this going to look like? Which council should we prioritise in engaging to do some pilot projects or a pilot study on different practices, as well as identify what are some of those best practices that have been implemented in different scenarios or different situations that we could look at in our stage 2. So we kicked off stage 2 late last year, and we have 2 councils on board, as you'll see there, our lovely team from Gladstone Regional Council, as well as the fantastic team at Whitsundays Regional Council. We really couldn't do this project without them and all their in-kind support in implementing the study sites. So at the study sites, we're hoping to capture finer sediment data to be able to establish those baselines and trial different practices. Stage 3 of the project is where we'll go into full mode of communication and knowledge transfer and pathways to impact. So really what we want to do with this project is be able to give all councils, particularly those within reef catchments, a best practice guideline on what they can do to help reduce sediment loss from their unsealed road networks and ultimately support the water quality of the reef. We are working with the GBRF at the moment to hopefully extend our project so that we can collect more data so that we can have a really robust result at the end of this project. Next slide, please. So just so everyone can see, this is an example of a study site setup. So this is what we have going in regards to both, in addition to this, we have pass samplers, which are pump activated sediment samplers set up across each of these different segments, as well as along a section of road to get a baseline for sediment loss. But these are some of the different things that we are trialing. So we're trialing primarily road drainage practices that could potentially help sediment loss, including V-drains with vegetation. We're looking at check dams. We're looking at stabilising polymers. We're looking at different maintenance and construction practices that councils can implement or have been trialled in the past by our councils that could help reduce that sediment loss. So that's just a bit of an example. Obviously, our segments are split up across a larger segment of road. They aren't right all next to each other, but that just gives you a bit of an indication of what we're looking to do. Next slide. Now, obviously, we're looking, or primarily our focus is the unsealed roads and the sediment loss from there, but we do understand that there is a lot of other data that we need to collect because it is a larger system that they're all a part of, and there's lots of different contributing factors. So we are working with our councils and the study pilot teams to be able to collect all of this different base data, including, you know, what are the connectivity to waterways, what are the construction practices, what are the land use types around the sites. So our Gladstone site has a solar farm right across from the road. So, you know, that could create different sediment flows from that particular site. We're capturing rainfall as well as road design at each of these sites. The point of doing this is so that when we get the outcome, hopefully some good outcomes from this project, as we are in the midst of it and don't have results just yet, that we'd be able to have something that is fit for purpose for our councils, and they'll be able to apply across different environments and be able to apply different practices that would best fit the situation that they have, whether it is extremely high rainfall, whether it's they are very close to gullies, etc. Thank you. Next slide. So to talk about key objectives just a little bit and what we want out of this, obviously I've said it a few times, we really want to establish the impact of unsealed roads on finer sediment making its way into Great Barrier Reef catchments and try and help provide a framework for councils to identify high-risk segments of their unsealed roads so that they know where they need to focus their attention to reduce that sediment flow. The second one is to identify a suite of cost-effective and practical measures. So with the work that we're doing, we are actually costing out what each of those different 8 different segments, how much that will cost a council depending on the length of road that they would like to implement it in, so that they can make a financially sustainable decision on which one would best suit them. And then finally, The big one is that we want to facilitate road manager adoption and implementation right across Queensland. So our hope is that we can work with key bodies, so state and federal governments, to actually implement the different best practice and the different findings from our particular project into technical specifications, funding guidelines, as well as best practice and training manuals that are delivered by our key partners in our project advisory group. So I think that was my last slide, if I'm correct. Yes, so here are my details. Please feel free to reach out. I'm happy to talk to anyone. Let me know if there's any other projects that you know about that focus in on unsealed roads and sediment loss. Let me know if you have any questions. You can enter them into the Q&A. But otherwise, thank you so much for having me.
Excellent. Thank you very much, Megan. I think there is one question at the moment in the Q&A around how are you going to develop the pathways to implementation?
Thank you, Greg. I can see that there. So how we're going to develop pathways to implementation is that we are in conversations with key peak bodies such as Queensland Reconstruction Authority, who have funding arrangements in regards to when there is a big flooding event around a road, or whether there is any disaster around a road that we want to implement betterment works as part of that guideline, so that our councils would be able to more easily and more regularly access funding to be able to, on a broader scale, implement the changes. We're also hoping to work with the Department of Environment and Science to advocate for a larger budget to do implementation moving forward, as they obviously understand the importance of this. And then additionally, from a federal perspective, there is a lot of road funding arrangements and a lot of initiatives that, once we can identify the safety risks of water quality in those particular settings, would be able to advocate for those to be implemented on a more federal basis. So then hopefully at the end of the day, we'll have both from almost like a bottom up and a top down approach, having lots of people be aware and understand how they can contribute to improving water quality through the management of unsealed roads. And I can see Mark has given me a question too, which is, are we targeting specific soil types? So we're not targeting a specific soil type. We are collecting data from our councils, from their environment teams on the ground, as to what soils are present at our study sites, so that we can provide informed decisions around what practices are working with what soil types. Hopefully that answers your question. Oh, I should press the answer live button when I've answered something, shouldn't I?
That's all good. Thank you so much, Megan. Okay, so we'll continue with our next and third presentation. So we have Kevin and Andrew presenting on virtual fencing technologies. Colby, if you can pull that out. Excellent. Okay, take it away, Kevin. You are muted at the moment.
There we go. We're good. Okay, well, thank you, Anna. And yeah, hi, my name's Kevin Fisher. I'm the head of operations and finance here at eShepherd, and I've got with me Andrew Zipson, who is our head of customer success. I'm going to just give you a brief introduction as to the eShepherd technology and a little bit about us, and then Andrew will actually talk about the trial that we undertook with the in collaboration with the Great Barrier Reef over the last year. So just to give you a bit of a background, so eShepherd is a virtual fencing and herding system that allows farmers to manage the location and movement of livestock from their computer, tablet, or mobile phone. The system uses patented virtual fencing technology developed by CSIRO here in Australia. Through the system, we're able to monitor the animal activity, well-being, and can send alerts to farmers' mobile phones. The system will allow us to rotationally cell graze or strip graze to optimize pasture utilization and regeneration, protect sensitive areas, or exclude livestock from waterways, all without actually leaving your home if desired. So somewhere there's a really good fit with Rebecca's previous presentation. We look like we've lost a bit of the information on this.
Yeah, maybe just press forward on the slides a couple of times.
Oh, there we go.
That's it.
So just a brief history quickly about the company. So founded as Agisons in 2014, the company was acquired by Gallagher, so a large privately owned company out of New Zealand, long history of animal management solutions, and we've been part of that larger group since literally for the last 12 months. We're run out of Melbourne, the eShepherd team in the southeastern suburbs of Melbourne, and have an innovation centre just outside of Brisbane in Queensland. We've got about 40 staff working on the product. To date have completed approximately 70 research trials on the technology, and then also have approximately 20 farm trials utilising in excess of 3,000 neckbands that have run to date. Currently focused on beta programs in Queensland and New Zealand. So in terms of the product vision, sorry, you can go back one page there, Colby. So fundamentally, the virtual fencing technology is all about containment initially. So to control the location and movement of the livestock in a similar manner to traditional barbed wire or electric fencing, but in this instance, no physical barriers and the ability to change them using a cloud-based application. The eShepherd technology trains livestock to recognize and stay within the virtual boundaries by detecting and responding to animal behavior using the patent technology that we've acquired through the CSIRO patents. In terms of animal performance, the second on the right-hand side there, so the user interface allows us to manage the animals, neckbands, mobs, virtual paddocks, and physical paddocks. We're able to monitor grazing with the virtual paddocks through what we've designed is heat maps. So it gives us an indication of the actual behavior of the animals. We're able to enable and disable virtual paddocks in the field, and then also receive notifications of any adverse events. So through the algorithms developed through, by our data analytics team, we're really kind of able to monitor through the user interface items such as feed efficiency, looking at things like white gain, location and compliance, and then also overall mob health and monitoring. Integration with so we're talking about the app, so the ecosystem integration. So again, the opportunity to gather all of this information. The Gallagher Animal Performance Map app was launched last year. And we're now looking at integrating all of the information that we can from the eShepherd technology onto this animal performance app that Gallagher has developed to provide unprecedented insights into animal performance. And then in terms of automated grazing, and I think this is a lot where Rebecca touched on in terms of the ability to strip, cell graze, rotational grazing through this kind of high density approach, high density to grazing approach as well. So that's the overall product vision that we have at the moment. And we're continuing to mature that. Colby, you can go on to that next stage. So really on a jobs to be done basis, we have through our product managers identified certain needs that the farming community have identified. The first really is that the ability for the eShepherd system to reduce the reliance on labor by automating the control and movement of cattle. That was certainly highlighted when we with the lack of ability to travel globally in the recent pandemic and the inability of the farmers to get in some extra labor. Also, if you have a look at the increased return on investment, there certainly is the ability there to improve the overall pasture management, deliver on actionable insights. And one thing, in terms of if we have a look at that actionable insights, an example we have from one of the customers we were working with is that we were able to alert the owner to an animal that had fallen behind the herd while they were using the functionality of the virtual fencing after it was suffering from what was known as 3-day sickness. The operators were able to remove the cow from the mob, help it to recover. So there's this opportunity to make sure we're looking after the well-being of the herd to increase that return on investment. Obviously, safeguarding the environment is something that's very dear to the project that we undertook with the Great Barrier Reef, and we're working very closely with the GBRF, and then Pamu Farms in New Zealand, where the legislation of keeping animal out of waterways, changes to legislation are to be enacted in 2025. So there's a real desire to look at this type of technology where physical fencing just isn't possible, just due to the underlying nature of the environment. And then also one of the underlying drivers behind the solution is this work-life balance, obviously, as we see the transition in terms of generations. We're a lot more tech savvy, and people want to spend a lot more time enjoying their time with their families. And we believe that the solution is able to provide this work-life balance going forward. Thanks, Colby. So just a very quick glimpse of the system. So we've got a neckband that's fitted to the animal. Positioning is determined via GPS. We have the base station that at the current, our current base station using LoRaWAN technology has a line of sight, a radius or a range of about 15 kilometers. And at this stage is able to stay in touch continually with about 1,200 cattle. We're able to then, through the smartphone, tablets, or for your web app, communicate via the cloud to that base station and send various GPS coordinates, changes, setting up the virtual fence to the mob, and to move them also. Yeah. All right, and that, sorry. So just in terms of the actual virtual fencing, for those that haven't had an opportunity to see it in operation, when the animal approaches the virtual fence boundary, the neckband emits an audio tone or a cue. If the animal ignores the cue and continues over the boundary, the neckband delivers an aversive but harmless pulse. Animals quickly learn to respond to the audio cue to avoid the aversive pulse while maintaining predictability and control. The eShepherd audio cues and pulse stimuli are automated, predicted, and avoidable. It takes up to between 2 to 7 days to learn, for the cattle to learn how to interact with the system. After this training period, they know how to respond to any virtual fence geometry in any location. That's the patent. As I said, the base station, self-contained, solar panel, solar powered, 15-kilometer range. At this stage, single person installation, easy to relocate, and as I said, up to 1,200 cattle reporting every 10 minutes through the current technology. So that's a very brief introduction as to the technology. I'm going to hand over to Andrew now to just discuss the actual project that we undertook up in North Queensland. So Colby, I think you need to go back one slide there. That's it.
That's
Thank
it.
you.
Great, thanks. All right, so yeah, a little bit about the project. So the aim of the project is the protection of the Great Barrier Reef from sediment runoff using eShepherd virtual fencing technology in sensitive riparian areas. So we partnered with an operator out there along the Burdekin River near Dalby. So yeah, it's somewhere in between Townsville and Mackay. A fairly large property on 130,000 acres there, and is running a Wagyu breeding operation with around 8,000 head. We kicked off the project in April 2021. We installed 2 base stations on the property, up on some slight rises on the property there, on some small hills, and we fitted 577 neckbands to begin with. And then over the course of the trial, we did scale that up to around 700 neckbands. The project ran for about 9 months, and it ended in December 2021. And I'll talk a little bit more about the conclusion of that trial later on. So yeah, as Rebecca mentioned there, like the typical practices for the region is set stocking. That's what most guys do. It's kind of the traditional approach. It's the least amount of cost that you have to put in, yeah, it's what's been around for years and years. At this particular property, the actual physical paddock sizes are between 600 and 1,500 acres, which is actually quite small for the region. Again, this particular guy has put in many kilometres of fencing to be able to put in higher rotations, but yet still not quite dense enough to get some of those benefits of the regenerative practices. So, and their last comment there about that rotational grazing, it is, you know, very expensive to put physical fencing in. There's a lot of maintenance that's required, especially in some of the areas near wetlands where it's prone to flooding, where it just wipes out all your fencing and you've got to rebuild it. So, yeah, difficult to achieve those holistic grazing practices with conventional methods. Let's go to the next slide. So with virtual fencing, we were using that basically to hold that mob of around 700 animals into much denser partitions inside the larger paddocks. So yeah, the stocking rates may not be high compared to, say, some of the stocking rates that we have down here in the south, but certainly they were very high for the region. And what we were doing there is really holding animals in parts of the paddock that were underutilized and had been underutilized for quite a number of years. So when you get into this, well, a trap where animals don't use that grass for some period, it becomes unpalatable and stale, and then that makes them even less likely to want to go there. So by using virtual fencing, we were really just holding them in some of these areas that had really were very unpalatable for them, and they had to just go and utilize that grass and trample the rest of it and fertilize the ground at the same time. And by doing that, you know, that regenerative practice of fertilizing the grass makes it come back greener the next year and juicier the next year, and then cattle all of a sudden want to go and hang out in those areas rather than spending all their time near the waterways where typically all the most nutrient-rich soils are and the juicier grasses are. So those places tend to get overutilized. So you can see there in these pictures, it's maybe a little bit hard to see on the screen here, but the two images are actually the same, and it's just showing on the right there. I've drawn the white box around the section that was virtually fenced. Now, there were actually no physical fence lines there, of course, right? That's just a virtual fence line. You can clearly see the difference in the pasture there where the animals were held over that period of time. And yeah, the farmer there took this picture with the helicopter, and he was extremely impressed with you know, being able to see what looked like physical fence lines when there were none. So it was a really good result. All right, we'll go to the next slide, Colby. Thank you. Yeah, so just on a little bit about the outcomes of the trial. So it was really one of the largest and longest running trials that we've done to date. Overall, animals were really well contained within the designated virtual paddocks, and that really demonstrated that rotational grazing practices are feasible in the region. Using the virtual fences, we were able to protect some of those most sensitive areas, those fertile grounds near waterways. We were able to rest them effectively, and we were able to utilize those unpalatable and underutilized areas, which will come back and become more attractive in the following years. So Rebecca touched on this as well, right? This stuff is really long-term, so you can't see the tangible benefits immediately. You can't see it in one season, that's for sure. You need many seasons of this before the benefits become apparent, but certainly, yep, that's the theory there is certainly being proven out by some of the CSIRO research that maintaining and improving the plant's root systems is really beneficial in terms of stopping sediment runoff. Now, during the trial, we did have some neckband reliability problems. They were mainly around the solar panels on that particular generation of the neckband. We did have a few solar panels that just developed some cracks due to thermal cycling, and that did lead, over time, it did lead to a reduction in the number of neckbands that were operational. So some of them just ran out of battery charge to maintain operation. And that did start to impact the trial over time. And we did have to close the trial off a little bit earlier than we would have liked. But really, it wasn't a huge issue. It's one that now the eShepherd development team is working on to resolve some of these technical issues to produce a reliable and robust product that is fit for purpose. And then finally, speaking with the station owner, he was really pleased with the results that he got, very impressed with, being able to just contain these animals in these virtual paddocks, having the flexibility of just drawing the virtual paddocks wherever you want was a huge benefit for him. And now he's really just focusing on saying, well, if we can resolve these reliability problems, and then technology has some immense potential to transform the way that farming is done in the region and really protect those sensitive areas and regenerate the landscape. So overall, it was a really good result, and we're looking forward to doing more trials in the area.
Excellent. Andrew, Kevin, thank you very much for that. Very interesting indeed. So we have 3 questions in the Q&A section, if you can go through them. The first one is in relation to the costs of the technology compared with conventional fencing. Yeah,
sure. So I can certainly answer that. Look, at this stage, the cost, we're still trying to kind of come up with a more suitable costing or, I suppose, pricing mechanism. Obviously, once we can get some scale and we're able to produce the neck bands, at a larger numbers, we will see the cost of that come down. So we're looking at, obviously, comparing those costs at this stage. The conventional fencing kind of sits probably alongside our virtual fencing solution, which is not, we're obviously trying to improve on that. Given that each animal has to have a neck band fitted. So it's kind of taking those benefits and looking, at the overall value proposition that the technology can offer versus the cost. So we're looking at, at the best way to get to market. We're still in that beta trials phase, and we're kind of looking at the monetization model, which is probably going to be a little bit of a hybrid between a hardware component and then also as a software as a solution type of component, and how we actually were able to get that out in mass to market. So it's still work in progress, but we certainly believe that once we're able to see more mass production of the units, once, as Andrew has said, once we can overcome the technical challenges, we'll certainly be able to scale up production and enjoy those benefits.
Christian's just asking the
current cost. Yeah, I know it is difficult. So at this stage, we initially stated that the current unit cost for the neck band was in excess of 300 Aussie dollars. That's based on very small, numbers being produced. And we need to actually, bring that down with over time and look at how we monetize that. So it's still very much based on, the initial kind of early stages of production, which at this stage we've, entered into some agreements for production in Thailand. In terms of ethics approval for use in breeder herd, we don't have, when we run trials, we have to have ethics approval for them. We're able to operate at this stage in Queensland, Tasmania, and Western Australia. Yep. Without any ethics approval.
That's right. Yep. There was a question there about the percentage of unreliable units. So, as I mentioned in my section there, the main issue that we had was with the degradation of the solar panels, and really, whilst the numbers were small to begin with, it did increase towards the later stages of the trial, where more of them fell over. And I think at one stage we got to about 17% of the neck bands that we had that were not functional anymore. And that's when really the containment started to become not very effective. So that's when we stopped the trial. But that was kind of the incident there. And I think those technical issues are already being addressed now. Sorry, do you want to just go back to the Q&A? I think there was another question about how long it would take to address them. Yeah, right. So look, we're working on the latest generation of the neckband at the moment. And we expect that, resolving some of these technical problems will go on for the rest of this year and maybe into early next year as well, until we have confidence in this latest generation.
That's right. So we've got new solar panels, new transformers, so to address some of these technical issues that we've just taken delivery of another batch today. So we'll continue to trial with selected trial partners, beta customers over the next couple of months to observe the new units, the new generation are in operation, and hopefully they're able to to address some of the shortcomings we saw in the previous version last year.
There is one more question, I think, around the ethics approval in there.
Right, yeah, okay, so for the breeder herd, right? So I think Kevin touched on that, but so as he said, in Queensland and Tasmania and Western Australia, we don't need an ethics approval for use in breeder herds, or any herd for that matter. So we can use the product commercially in those areas. Of course, it hasn't been released commercially yet, but we could. And certainly the trials that we're running there don't need approval. But in other states, if we are doing research trials, we do need an ethics application.
Great, excellent. I think the other questions have been answered already. Yep. Thank you very much to both of you. We'll kick off with the next and final presentation from Greening Australia. We have Martha and Johannes talking about the use of drones in riparian restoration and wetland restoration. Give it away, Martha.
Thanks, Anna, and thanks, Colby. So I'm going to talk about our project, which is trialing the use of drones in riparian and wetland restoration. Next slide, please. Our project is being delivered on the traditional country of the Wanyamadaje, the Yidinji, the Bindal, and the Darumbal peoples in the reef catchments near Cairns, Townsville, and Yeppoon, and just acknowledging the land that we're all sitting on today as well. Next slide, please. So my name is Martha Kasetic. I am the technical lead for Greening Australia's Reef Aid. We're working to improve water quality for the reef by restoring wetlands and gullies in the GBR catchment. Next slide. So a little overview of this project, working in riparian and wetland habitat restoration for the reef catchments. So if the people here have worked on those kind of projects before, you might be aware that projects in these areas are often constrained due to remote access, boggy terrain, and safety issues, such as crocodiles. So there's some limitations to working in these types of areas. And what we're doing is looking at comparing drone applications to manual efforts for monitoring weed control, seed dispersal, and to determine the cost effectiveness and best practice guidelines for when we can use drone applications in these types of areas. And we're working with and sharing learnings with our regional partners in all of these different catchment zones. Next slide, please. So we know that riparian restoration is important for reducing sediment loss to the reef. This is an image of the Burdekin River flood plume reaching out to the reef. So just a very visual example of how that can be affected. So in our current project, we're hoping to improve soil retention. However, we're not assessing the water quality directly. And other outcomes and benefits of riparian restoration include improving the water quality relating to nutrients, repairing wildlife environments and habitats, and for community enjoyment. Next slide. So the scope of our project is to evaluate the applicability and cost effectiveness of drones for seeding, mapping, and weed control. We began the project last year, so we have implemented the major drone applications in the first half of this year, and we'll continue with monitoring and analysis until June 2023 next year. Some of the limitations to the scope include the site conditions and weather impacts. And the scope for the type of drone seeding and the analysis of the drone imagery have been determined by the project timeline and budget. Next slide. This is an example of our experimental framework. We're working in situ trials, and our methodology has been developed through consultation with drone experts, regional partners, and with consideration for the project scope and budget. And then we've modified this approach by site as needed. So in the wetland and riparian work site, we're doing drone weed control when applicable across the whole area, and we're doing drone monitoring across the whole area as well. And then the site is divided into 2 main zones, which you can see here for the seeding trial, comparing the manual and the drone seeding applications. Next slide, please. We have 3 sites along the GBR catchment. The first is Ross Road, bordering the Mulgrave River near Cairns. The second is Viv Cox along the Barada Creek near Townsville. That's what you can see in this photo here. And the third site is Big Dune, which is set between coastal wetlands and the beach near Yeppoon. We work with many partners in each region who have all had valuable input to the project. I won't read them all out, but they're listed here for you. Next slide. So for implementation at the first site, Ross Road, we have implemented drone and manual monitoring, and we've implemented drone and manual seeding as well. In this first image, you can see an example of the output from the drone monitoring, which is a high resolution orthomosaic, and that can be used for analysis of vegetation cover and other things as well. And the second image is actually a video. So Colby, if you could please play that. It might be a little bit hard to see. You can maybe play it a couple of times and I'll just explain what's happening. If you can see on the screen of the controller that there are little flecks coming down, that's actually the seed being dispersed from the drone during the drone seeding. And that's the view from beneath the drone. It can be really hard to see from a distance. So that's an example of where you can see the seeding coming through for the drone. Thanks, Colby. Next slide. And this is a video as well, if you'd like to play that one. So this is the seeding drone as well at Ross Road site. And you can see it takes off and then moves to the drone seeding area. And the seed in this drone is held inside that main container at the center of the drone and dispersed beneath the drone like we saw in the last video. And in this particular example, the operator has programmed a grid flight for automated flight. And so the drone is just picked up on that flight path right there and will continue in a grid pattern. And they can also do a manual flight as well. So it just depends on the site. Next slide, please. For the second site, which is Viv Cox, we've implemented the drone and manual monitoring. We've implemented the drone weed spraying and the manual seeding. So in the first image here, you can see the manual monitoring transect for vegetation assessment. And in the middle image, this is the weed spraying drone. So the chemical goes in the central compartment and is sprayed out through the 4 arms of that drone beneath it. And in the third image, that's the seeding drone. So different to the previous video, the seed container and hopper are hung beneath the drone. Next slide, please. And this is for the third site, Big Dune, and we've implemented drone and manual monitoring and drone and manual seeding, again with the seeder and hopper hung beneath the drone, and that's just a bit of a close-up of the drone. Obviously, a lot larger drone is used for the seeding applications so that it can hold the weight, and similarly for the weed control, whereas monitoring can be done with a much smaller drone. Next slide, please. So since we've just completed the seeding trials last month, I don't have a lot of results to discuss yet. However, I can share some initial learnings. Some seed size and shapes are incompatible with the drone seeding mechanism. However, this is drone operator specific. You can see in the first 2 images, various seed sizes and textures. Our operators were able to adjust the aperture to distribute these seeds successfully. Most operators suggest using a round seed under 1 centimeter that can be a mix of species or a single species. However, it's a good idea to discuss the options with the operator ahead of time and provide samples so that they can assess what would work for the drone and potentially make some modifications. So site surface preparation needs, weather condition, and canopy cover can also influence the budget and drone implementation approach. And operators may have different capacities and mechanisms for distributing seed. As you can see in this third photo, our operator brought a claw attachment that was able to disperse these helicopter seeds, which have that little wing on them. And those wouldn't fit in the normal drone seeding hopper, but they were able to be dispersed in this way. So this allowed them to kind of float down when the claw was released at a height, and that saved breaking up the seeds and trying to fit them through the other type of hopper. Next slide, please. Looking forward, we're continuing work on monitoring, maintenance, and analysis. And we're also doing a germination comparison trial with James Cook University, which you can see in this first image here. And the two main outputs of this project will be best practice guidelines and a cost effectiveness matrix, ultimately developing pathways to improve costs and accessibility of riparian and wetland restoration work. I think that's about it. There's one more slide. That's just if there are any questions. Thanks.
Thanks, Marta. I don't see any questions as of yet in the chat, in the Q&A section. So great person.
Maybe I'll ask a quick question.
Sure.
So with the drones, like how much seed can they actually carry? I mean, how much area can you spread that to before you have to come back to refill?
So the amount of seed that they can carry is drone specific, just by the kilos that they can carry and the battery life that the operator has. In general, it's over 5 kilos that they could carry potentially, but it really depends on the size of drone that you're using. And how often they have to come back and refill depends on the seeding rate, and similarly for what area they can cover. So you can adjust the aperture and speed of the drone. So the aperture for the dispersal volume of seed, and then the speed of the drone to achieve different seeding rates. And it can be quite accurate when the drone is on the automated pathway, and sometimes a little bit less accurate when it's manually operated. So it's usually a good idea to do a short one length run trial with the operator just to get that accuracy. And yeah, basically you can adjust the distribution of the seed and the rate to cover potentially, more than half of a hectare with one approach, as long as the battery life can last that long for the drone. So it's just about the distance that it needs to travel back and forth as well.
Yep, thank you.
There are quite a few more questions coming through, Marta.
Okay, let me open those up. Okay, so what is the area a seeding drone can cover? So I think we've kind of addressed that, but basically it can cover as big of an area as you want to, as long as you have enough battery, and it will have to come back just to keep changing out the batteries on the drone. Okay. Let's see, success is likely to depend on follow-up weed control. Yes. Is this able to be performed by the drone or more traditional methods? Both are options. So we are trialing our drone weed control, and we've used manual weed control as well. We are waiting on the timing of the follow-up post-seeding just to look at how our germination progresses before we determine which approach we'll use and when. But yeah, we are able to do drone weed control as a follow-up. And we can use a selective herbicide for that as well to target the species that we want to remove. Okay, are the preliminary results on germination efficiency for the method? No, that we don't have any results yet. So we're going out really in the next few weeks to the 3 sites to look at germination, just because the seeding was so recent. And then the trial in the greenhouse, there has been some germination, but we haven't, put together those results. But we do have some germination coming through in the greenhouse, which is to be expected. And we did have viability testing done on the seeds as well to ensure that we were using viable seeds for our distribution also. Okay. Let's see, very interesting. How do you plan to monitor and do the maintenance? So monitoring is, because this is kind of an innovative trial, we're doing two types of monitoring. One is manual vegetation monitoring with transects and quadrats in the 2 trial zones. And that is biannually, but also we've done an additional, we're doing an additional germination at about 6 to 8 weeks post seeding for an additional check for the germination. And the maintenance is mostly that weed control maintenance, and it's planned for pre-wet season. We will adjust that as needed upon the site visits that we do, just to understand how the site is responding and what the weather conditions are, because we've had quite an unique wet season so far. So we're adjusting the plans as needed. How have you determined seed species selection? And where did you source your stock? That's a great question. That was a big component of the project. So we looked at the regional ecosystems lists for the different sites, and then we worked together with local nurseries to do some site assessments and determine a broad species list that would be suitable. And that consists of trees, shrubs, and grasses. And then we looked to those local nurseries for seed procurement. And we also ordered from a Queensland-based nursery to supplement when the local nurseries didn't have enough supply. So mostly it was quite local for the seed sourcing, but a little bit broad as well. And I think that might be it. Are there any other questions?
I think that's it. Thank you very much, Martha. That was a great
Thanks.
presentation. So if anyone has any other question to any of the presenters, please just put them in the Q&A section. If not, I'd like to thank our presenters first. You did a great job, and please continue doing the great work that you are doing with the projects. It is really like these innovation projects. We feel that they are really promising, and yeah, I'm very, very keen to get to the final stage and see the great outcomes to be achieved. And yeah, thank you very much, everyone, for attending. As I said, this is our first webinar series. We are organizing the second webinar probably in a couple of months from now. And next, what we will do is to share the presentations with the attendees, and we will also be posting the recordings on our website. So have all a very good afternoon, and thanks again. Bye, everyone.